Okay, we move into Chapter 6, Section 6.1. We will divide, multiply, and simplify rational expressions. So before we get to that, let's work on these warm-ups, all prerequisite skills that we need to move into Chapter 6. Go ahead and pause the video and see how you can do. Okay, number 1 is just foiling, and number 2 is just factoring, which is a very big part of Chapter 6 that we need to know how to factor. Number 3, we are working with some fractions, since rational expressions really are fractions. I'll explain that in a minute. You need to know your basic operations with fractions. So first thing that we're going to do here is we're going to distribute the 5/7 to both the 14 over 30 and the 7 over 5. Then I can cross reduce. 14 over 7 reduces to 2 over 1, and 5 over 30 reduces to 1 over 6. Over here, 5 over 5 just becomes 1 over 1. 7 over 7 becomes 1 over 1. Now I can multiply straight across in each of those. 1 times 2 is 2, 1 times 6 is 6, plus 1 over 1, which is 1. Or I'll just leave it as 1 over 1, common denominator, 1/3 plus 3/3 is 4/3. Now this last question here, Tom can mow a lawn in 4 hours, Perry can mow the lawn in the same lawn in 5 hours. How long does it take them working together? This is something we don't get to until the end of Chapter 6. This is just kind of giving you a heads up of what we're going to be working towards. So what I want you to try to do is just come up with a guess, and we will discuss this a little further in class and much more in detail later on. Okay, so what are rational expressions? Well, think about what rational numbers are. They're just numbers that are basically can be written as a fraction when you think of a rational number. So 3 over 4, obviously it can be written as a fraction. It is a fraction. 0.4 can be written as a fraction, 4 over 10, or 2 over 5. -5 can just be written as -5 over 1. And 3.5 can be written as 7/2. So those are rational numbers. Rational expression is the same idea, except now we're bringing variables into it. Remember, all of Chapter 5 had to do with polynomials. So a rational expression, it's just a quotient of two polynomials. You're just dividing two polynomials. In this lesson, we discussed simplifying rational expressions and multiplying and dividing them as well. And then we get into adding and subtracting. But simplifying rational expressions, that's something that's part of this entire chapter. Okay, so you need to understand the major concept that is really described right here. If we had something like AC over BC, this is just division here. A times C over B times C. C is a factor because it's separated by multiplication up top and on bottom. And think about what C over C is. C divided by C is just equal to 1. Therefore, they would cancel out. You can just cancel them out, and you're just left with A over B. So our main process for simplifying rational expression is explained right here. We're going to be doing a lot of factoring. We're going to factor the numerator, factor the denominator, and then you're going to cancel out or divide out any common factors. Like here, our common factor was C. They cancel out. So this explains what a rational expression is. I would definitely star this somehow. This is a very important rule. Like I said, pretty much every problem you're going to be working on for the next week or so, you must abide by this. You cannot cancel terms. You can only cancel factors. Okay, terms are separated by addition or subtraction, and factors are separated by multiplication. So keep that in mind. Let me explain that. Let me explain that with this very easy first example, 5 over 10. Now we know this reduces to 1/2. That's pretty basic. But I want you to look at it by abiding by this rule. If I factor the numerator, I could look at 5 as 5 times 1. And if I factor my denominator, I could look at 10 as 5 times 2. Now the 5 in the numerator is a factor because it's separated by multiplication. Same with the 5 in the denominator. Common factors cancel out. I'm just left with the 1 over 2. So your answer there is just 1/2. Similarly, for letter B, I could rewrite 18 as 6 times 3, and I could rewrite x squared as x times x. And down below, I can just write 6x as 6 times x. I have a common factor of 6 that cancels out, and I also have a common factor of x that cancels out. So I'm just left with 3x. Now you could probably get to this a little quicker just dividing 18 divided by 6, which is 3, and x squared divided by x. Do your properties of exponents, just subtract them. 2 minus 1 is 1. So that's another way you could look at it. Letter C, you have to be careful, and you really have to abide by this here, because a very common mistake people make is that they cancel out the x's and they just call it 5 over 10 or 1/2. But notice that those x's are not factors. They're actually terms because they're separated by addition or subtraction. You have one factor up top. This x plus 5, that counts as one factor. Over here we had multiple factors. We had 6, 3, x, and actually 6 went down even further. You could have called this 6, 2, and 3. But there's nothing you can do here. You can't really factor this anymore, this x plus 5. Same with this x plus 10. The factors are not the same, therefore you can't do anything. You can really just leave it as is. It's already simplified. Already simplified. In letter D, we want to factor the numerator. My GCF is a 5x. I'm left with x minus 3. And in my denominator, it's really already factored at 10x squared. But I do notice that the 5 over 10 reduce. 5 over 10 reduces to 1/2. And also one of my x's cancel. This x cancels with one of these x's, just leaving an x down here. So I'm really just left with x minus 3 over 2x. And make sure you don't try to cancel these x's. That would be wrong. Even though this x down here is a factor because it's separated by multiplication, this x up here is not. So you cannot cancel it. They both need to be factors. Multiplying is the same idea. You could really almost just kind of, since when you multiply fractions, you multiply straight across, you can really just kind of write this as one rational expression and combine it to be one single rational expression if you wanted to look at it like that. So this is why you need to know how to factor. We have 4 factoring problems oftentimes for these. I need to factor both sets of numerators and both sets of denominators. So my first numerator is x plus 4 times x minus 4. My first denominator has a GCF of 2, and I'm left with x plus 3. My next numerator, x plus 3, stays, and my denominator stays as well, x minus 4. Now that I have everything completely factored, I can look to cancel out common factors. And I can only cancel them out if I have one common factor on top and the same one on bottom. So here I have an x minus 4 up top and on bottom. They go away. The x plus 3's cancel, and you're just left with x plus 4 over 2. Now don't try to reduce this 4 and this 2 because this 4 is part of a factor. This 4 only represents a term, and I cannot do anything with that. Looking at letter B, I have a lot of factoring to do here, and when I do that for my first step and factor everything, I would get this right here where there's a lot of factoring. I think I had to factor 3 different polynomials there. The only one that didn't factor was the second numerator, and you'll notice that you don't want it to factor anyways because it's going to cancel with that trinomial there. So we had difference of 2 squares, difference of 2 cubes, and a perfect square trinomial. My a minus b's cancel, and another factor that cancels, I have one a plus b up top, and I have 2 of the a plus b's on the bottom, so I can cancel one of them out, and I'm left with an a plus b on the bottom. But remember that a plus b is in the denominator, and you don't want to say you're just left with nothing up top. You're actually left with the 1 up top. So your final answer would be 1 over a plus b. Division is pretty much the exact same thing as multiplication, except there's going to be one added step. Remember, if you're ever dividing a fraction, the step is to keep the first fraction, or in this case rational expression, change the division to multiplication, and then flip the second fraction. So we keep, change, flip. I'll do that for both steps right now because that first step should be very easy when you have division. Okay, so you just keep the first rational expression, change the division to multiplication, and flip the second one. Now we're just back to a multiplication problem. So we know what to do from here. We do all the factoring first. Then I cancel out common factors. So 2x minus 1's go, x minus 2's go. That's it over on that one. Over on this one, 2x plus 3's go, the 16x squared plus 4x plus 1's go. And I think that's it. And then you just record what is left. And that's that. So why don't you go ahead and pause the video. You have a lot of checkpoints here to get through. Actually have 8 of them. Why don't you go ahead and pause it, take your time, and try to work them out, see what you can do, and then come back and see how you did. Okay, go ahead and check to see how you did. In letter C, I just want to point out that after you did all of the factoring, none of the factors were common factors, so you couldn't do any canceling. D through H, just a lot of factoring for each of these problems. Remember to keep change flip on the division problems. And looking at letter H, there's a little trick here. If you look at 1 minus x, that is not the same as x minus 1, so you can't cancel out those as common factors. So what I can do for each of these x minus or 1 minus x's, I can put them into standard form by factoring out a negative 1 from each of them. Now I have a common factor of x minus 1 that can cancel. And I'm still left with 2 more x minus 1s in the denominator. And then negative 1 times negative 1 times negative 1 is a negative 1. So this is what you would get. Looking at the closing question, the answer here is no. Why someone would say yes is they cancel terms. They reduce the 7 over 7 to 1. And then they canceled out one of the x's. But remember, you can only cancel factors. You cannot cancel terms. Your homework is 6 through 40 even. And I did one of the tougher problems here on the next slide, so you can see how to do one of these tougher ones. So this is number 33. I know it's not part of the assignment, but you're going to see some problems like this. So you can see the denominator is already factored. But notice in the numerator, you cannot just cancel out these x plus 1s. Don't fall for that trap. I know it looks like that first x plus 1 up here is a factor, and it is, but because of this subtraction here, that does not make it a cancel. You cannot cancel it as a factor yet. You need to expand everything up here, and then factor it, and then look to cancel out common factors. So in my numerator, I will distribute the x to get x squared plus x. Distribute the negative 2 to get minus 2x minus 6. And my denominator will stay the same. Now I can collect like terms up in my numerator with the x minus 2x. That would actually just become minus x. Now I can factor the numerator as x minus 3 plus 2. Denominator stays the same. Now I have a common factor. Now that everything's completely factored, now these x plus 2's can go. And I am left with x minus 3 over x plus 1 times x plus 3. So good luck on your homework.